Hello students, welcome back. So let us continue to look at assignment 8.3. So let's begin. Here we have a graph showing the cost, we call it C, right? Sending a parcel of mass M kg overseas. So let's see what they want. The graph is given to us. They want us to find the cost of sending a parcel overseas if the mass is 40. So the mass is on the x-axis. What we can do in for this particular type of question, we can actually use the dotted line here, right? So looking at mass 40 kg, if I were to draw the dotted line up here, right, and then trace it over on this side, you'll find that the value over here is actually 140, right? Therefore, okay, the answer here is $140. How about 76? Again, the same procedure. Looking at the graph, I look for 76, which is over here, okay, and then I mark it over to this side. And you'll find that this value over here is 230. Therefore, the answer is $230. How about the reverse? Checking reverse is the same process. This time around we have $50. We want to find out what is the cost. So $50 is over here, right? So if I mark it out and then I push down, oops, right? You'll find that this is actually 4, therefore it is 4 kg. Okay, how about $260 using the same process, right? So 260 is over here. So I trace it to the graph, right? And then after that, I trace it down. Right? If you draw it accurately, it should be right over here. This is 88. So 88 kg. Okay, so this is just using the graph, and then you can use a ruler, use dotted line to help you. You should be able to figure out the correct solution. Okay, now the next question they want us to actually okay, so what we do here is before we get started with the graph, let's do the first step, which is to complete the table, right? So how do we complete the table? We just make use of this function over here and substitute accordingly. So when x is equals to 10, 0.2 times 10 is 2, 2 plus 4 is 6, so that's how I got this value. Then repeat again when x is 20, so 20 times 0.4 is 4, 4 plus 4 is 8, that's how I got this value. And then when x is 30, 30 times 0.2 is actually 6, so 6 plus 4, 10. With this, I get my table successfully completed, right? Then I move on to the graph paper. Using the scale of 4 cm to represent 10 gram, draw the horizontal axis, and then using 1 cm to represent 1 cm, right? Draw the vertical axis. So follow accordingly, right? So over here, as you can see, 4 cm, I wrote 10, 4 cm, 20, 4 cm, 30 for the horizontal. On the vertical, every 10 cm is, every 1 cm is actually 1 unit. So we have that. Label the axis X and Y. And for the points, I'm going to plot the points. Okay, so the points here, each column here is actually a point. So over here, this is actually, let me write that. This is actually 10, 6. This is actually 28. And this point over here is 30, 10. Okay, so mark out these points, right? You can see they are actually marked out. Let me just make it red so that it's more obvious on your screen. So with this, we join them together with a ruler, and don't forget to actually label the graph with the function. So that's how your graph should look like if you have drawn it successfully. And then from here, we can answer the questions, right? So the question is, find the length of the spring. Let me zoom in. When each of the following masses is attached to it. So they want to look for the situation where it's 25 gram as well as 18 gram. So all we need to do is look for 25 gram. Let me use a dotted line, red color. Should I keep it as red? Well, red is fine. So sorry again, let's take a look again. 25 gram, so look for 25 grams. 25 grams will be somewhere here. Yeah, right in the center. Use a ruler to help you. And then, oh, I shouldn't use red, it interferes. It's okay, it's fine. Okay, so you do the dotted line, you'll find that end up with at 9, right? So therefore, it is 9 cm. And then we repeat the process this time round. Let's take a look. 18 gram. So 18 gram, right? We end up with 7.6. So here we have, let's mark it out. Okay. Oops. Let's use the line properly, right? If I mark this one out, okay, and then I go this way. Oh no, my cursor is going everywhere. Okay, let's do it from here. Come on. Okay. Right, so this one you end up with 7.6. And now it's 7.6 over here, right? 7.6. Okay, so that's how your graph looks like. And then answer the last question. Explain the significance of the y-intercept. So the y-intercept is over here. What happens at this point? This is the point where the spring is actually not stretched at all, right? So it is the original length of the spring, right? Original length of the spring, 4 centimeter, when there's no mass attached to it. So just write it out in proper English and you will do fine. So that's the second question. Let's take a look at the next one. Okay, the next situation, we show a graph that shows Jimmy's journey from home to school. And he left home at 8:30, walked to the bus stop, traveled the rest on the bus. Okay, so let's see. How long did Johnny wait at the bus stop? So I can mark it out that this basically is over here, right? He reached the bus stop here, and this is the place he waited, right? As you can see, while he's waiting at the bus stop, his distance from school doesn't change. So it is from 8:33 to 8:40, that is 7 minutes. How far was he from school at 8:45? So at 8:45, okay, we check out at 8:45, he is actually over here, right? So this is the amount that he, this 3 kilometer from home, and this is a school. So this distance over here, if we measure it, it is actually 2.6 kilometer. Okay. Now, finally, they ask us to find the gradient between 8:40 and 8:50. So between 8:40 and 8:50, that's the gradient. So how to find the gradient? Well, all we need to do is find the rise over run. So this is the rise. We can actually mark out this portion here. This is fine. How many units is this? Well, it is actually 5.6 units, right? You measure it. And then from here, 8:40 to 8:50 is 10 minutes. So sorry, this, let me mark it up properly. This is 5.6, this is 0.4. Therefore, the distance over here, the rise is actually 5.2. Whereas over here is 10 minutes, right? So 10 minutes is actually the same as 1/6 hours. Why do we want 1/6 hours? Because we are going kilometer and it match with hours, so that when we divide it, we get kilometer per hour, right? Nobody go kilometer per minute. It just feels weird. So we work it out. This is the gradient is 31.2 kilometer. What does it refers to? It is the speed of the bus, because that's the part of the journey where he's actually on the bus. Does this make sense to you? I hope it does. If not, let's read the question again, and after that, look at the solution one more time, right? Okay, the next part. Here we have Jimmy's neighbor Ken left home at 8:35. So he left home a little bit later, but he cycled at a constant speed and actually managed to reach school 1 minute before Jimmy. So he's actually cycling while Jimmy is waiting for the bus, right? So shows Ken's journey on the graph. So what happened is this line over here, this is actually Jimmy, right? And this line over here is actually Ken. Oops. Ken. Okay, as you can see, he started at 8:35, and the distance, they go to the same school. So you can see, let me change the color here. Okay, this, okay, I should use a line instead, blue line. Okay, you can see this is the school, right, at 5.6. So the distance schools same, right? But 1 minute before, right? So 1 minute before, so instead of 8:50 is 8:49. So at 8:49, you can mark it out if you want to. This is 8:49. I mark it out with the green dotted line, and that's where Ken actually ends his journey. Okay, So all we need to do is we need to actually be comfortable translating all this information, whether from the table form to the algebraic form to the graphical form, to actually present all this data in a large variety of ways, and that's one of the main objectives for this particular chapter itself. Okay, so with this, I hope you're successful. If not, well, do your corrections and learn from the mistakes and continue to improve. All the best.